long way. We've come a long way. Today's supposed to be, or should be, our last class of SQL, right? And if you remember, the program is Git, SQL and Git. So what that means is that what we have left is to discuss Git if we're able to finish today, right? Of course, a whole lot of us were not able to make class yesterday, so we're only able to do just one chapter, right? But I can assure you that next week we are rounding up this training, wrapping up this training next week. Wrapping up this training next week. And I hope that we have enjoyed a great time in this training. I've learned few things in this training, right? Hold on. Coming. All right. So we're wrapping up this weekend, right? We're wrapping up this weekend. I mean, next weekend. But today is supposed to be our last class of SQL. So yesterday we spoke about joining, right? I'll drop the videos for us to be able to look through, right? We spoke about joining yesterday, and we talked about joining as the last part of joining as the last part of the select statement, right? Remember, a select statement is meant to do three things: selection, projection, and joining, right? So we started talking about joining, and we said joining is done when you combine or when you get results from two or more tables, right? When your query returns or fetches data from two or more tables, we say joining has been done, right? So, and then we looked at the different kinds of joining that is available or that we have. We have inner join, outer join, and cross join, right? We talked about inner join, outer join, and cross join. Inner join, outer join, and cross join. And then we said with inner join, we talk about the using clause, using using the using clause to join data together, right? And we talked about the fact that for you to be able to join with an inner join is also known as equal join, right? It means that for two tables to be joined together, they must have two things in common. They must have a column that has the same name and the same data type, right? And when you're about to do that, when you have a situation where you have a column that is shared among two tables that has the same name and the same data type, then you can join them using an inner join or an equal join. Using as a clause or using on as the join clause, right? So here we are using. So we're joining these two tables together, right? It says from employees join inner joins department, right? So it can be written that way. It's the same thing as saying from employees join department. Can you see? It's the same thing. It's the same thing actually. It's the same thing, right? So So from employees joins department, or from employees inner joins department, using what? The column, this column, to tie both tables together, right? Then we also looked at uh, creating views, right? And remember, when we're talking about create table, I said we're going to talk about create views when we talk about joining, right? And we're joining this table, right? We joined the same table that we joined, right? I taught you that create table, or create view, sorry, is a view is an object that does not hold its own data, right? It relies on order of the other tables to give it its data. So when you create a view, when you create a join statement, right, what that means is that because the data is the table, the resultant table from a join statement is not permanent, right? It's not permanent. That is, it's as a result of the SQL statement that joins the two tables together, right? It is a pseudo table, meaning that the table is not permanently stored in the database. So for you to be able to store a join statement, or the result of a join statement permanently, or yeah, you create it as what? You store the result inside a view, right? And we said create. How do you create a view? You use the create or replace view, and then we give the name of the view as this. As select all from all of these and performing the joining, right? And if you look at the table here, if you look at the view here, you'll be able to see the view. Can you see? This is the view that we created. Can you see? That's the view that we created. So you can now write an SQL statement against the view. Can you see? We can now query the view itself. We can query the view itself, right? And say select all from emp underscore location underscore 1400 underscore view, right? Right. So that is how to create a view and store the data of the view. I mean, create a join statement and store the data of the join statement in a view, right? We also talked about joining tables with aliases, right? And we said that we use alias to qualify ambiguous names, or names that are too long. We use aliases to qualify those kinds of names, right? And I explained further yesterday that when we are joining tables, right, and the tables are getting their data from multiple columns, right, you want to be able to specify, to say that this data or this column is coming from this table, this data is coming from this table. So we started from saying that we give an alias to the employees table, take for example, and call it employees E, and give another alias to the departments table, and we call it department D, right? So therefore, what you have in this place where you see e dot that is employees ID, employee dot last name, employees dot salary, employees dot department ID, department underscore department ID, department dot department underscore name, department dot location ID. Why? What do you mean? We'll say that the employees ID is coming from the employees table, the last name is coming from the employees table, the salary is coming from the employees table, the department ID is coming from the employees table. This department ID is coming from the department table. The department name is coming from the department table, and location is also coming from the department table, right? And of course, we're using a where clause in this situation to restrict the result of the query to just locations, where locations ID in 1400 and 14 and 1500, right? So that is how to use aliases in joining a table, right? And of course, we saw a three-way join as well yesterday, where we joined three tables together, right? We joined the employees E to join to the departments D using department ID, and then we now join that department ID column, table, to the locations table using locations ID. Now, how do we know which column to use to join a table together? I remember I said yesterday that the way we know is that because the tables are linked together through primary keys and foreign keys, foreign key tables are the ones that we use in joining tables together. Foreign key table columns are what we use in joining tables together. So we also looked at using the on clause, right? Using the on clause to join tables together. We also look at the on clause, using the on clause to join tables together, right? And we're also talking about non-equal join, where we're talking about the left outer join tables, left outer join and right outer join. And we said that the left outer join, when you're using non-equal join, in the first instance, you're saying that in the equal join statement or the inner join situation, what we are saying is that this column are the same on both tables, right? So that's why we call it an equal join. That is, the data in both of them are the same. But for the non-equal join, we're saying that one table, the tables that we are joining together, the columns inside of them are unmatched. That is, one column, even though it is the same column, same name and data type, one column has one data than the other. So it can be the employees table, or it can be the table on the left that has more details than the table on the right, or the table on the right has more details than the table on the left. Right? So in this situation, we're saying that the employees table has more information than the department table, right? And that's why we say left outer join. So what you are saying is that left outer join departments D, right? So which means that this employees table is presumed to have the department ID column from the employees table is presumed to have more information than what the department ID column of the department table, right? Then to flip it around on the other way, we have the right outer join, which means that the department table has more information on the department ID column than that of the employees table, right? Then we also talked about castation products, which is the cross join, and we said cross joins are situations that we want to avoid, where you put everything in a particular table into all the rows in a particular column, right? Please, if you this is just a revision, right? I would advise that when I drop the video this night, to understand joining, please go through it. Go through the video. I explained extensively all of this concept in that video. So please do engage the video to understand more, right? So we want to jump into what we came here to do, right? Today, right? So today we want to quickly look at subqueries. And when we talk about query, right? What we are saying in subquery is that you have a query inside a query. Basically, that's what you're saying. You have a query inside a query. That is all, right? So it says a select query inside a select query. That's basically what we are trying to do. So when we talk about subqueries, right? Like I said, it is not hard. It's the principle that you will know before, except that we're just nesting select statements together. So today, which is 17th. We're looking at subqueries. Please let me know if you are with me. Let me know if you are with me. Please let me know if you are with me. Vivian, Lola, IBK, John. Are you with me?
Yes, I'm with you.
Awesome.
I have to really go back to the previous videos for me to be able to catch up and follow. I had funeral. We were attending to lost someone very close, so that's why all the while I wasn't following for over 2 weeks now. But I'm back.
All right. Welcome. Sorry about the loss. Welcome.
Thank you, sir.
All right. So everybody should treat this subject or this topic in isolation. Don't relate it to the topics that we've done before, right? Don't relate it to topics that you missed. Treat this topic in isolation, right? Just learn the concept as I'm teaching it. You can easily go back to the videos that we have or that we have of the classes that you've missed, right? They are all on YouTube already. So, except for yesterday's class. So, but treat that topic, all those topics in today's topic in isolation from those ones, right? So that you can understand the concept of today's class. Awesome. So today we want to talk about subqueries, right? And I said a subquery is a query inside a query, basically, right? So what does this mean? It means you're saying that a select statement inside a select statement. That's what that means, right? That's basically what that means. You're saying a select statement inside a select statement. That's basically what that means. So we want to look at the syntax of subqueries. Syntax of subqueries. So you say that what you have is select so we can say column underscore list, right? From table underscore name, right? Where column underscore name equals select column underscore name from table underscore name where column underscore name greater than value, right? So basically, this is how a subquery looks like, or this is what a subquery looks like, right? Basically, this is what a subquery looks like. So you're saying that what you have is a query inside a query. So we say a query inside a query. You can see that this query here is inside this main query. So we call this the inner query, and we call this the outer query. Are you following me? We call that the inner query, and we call the one the outer query, right? Or we call this the child query. Right? And you call this what? Of course, the parent query. The child query and the parent query. Right? That's what you have in this situation. So subqueries are as simple as this. And the question will be that why do we use subqueries? Why do we use subqueries? Subqueries are situations or helps us in situations where we just want to know about something or want to query the database about something, but we do not know what exactly what to query it about. But we have an idea of something related or something that can relate us to what we want to create database about. So basically, say I want to, let me give you a practical example. Say I want to know what is the let me think of a good example now. Hold on. I think I have a perfect example here. All right, so we want to know who receives. So an example of this would be that. So example. So we want to know who receives the least salary in the company. Who receives the least salary in the company? Are you following me? Right? That's our question. So, but yeah, what is missing is that we don't know the two things that we don't know. Right? So to answer this question, we don't know two things. We don't know what the least salary is. We don't know what least salary is. We don't know who receives the least salary, right? Those two questions we don't know. So how do we solve it? First of all, we need to find out what the least salary is. Then that will help us what? Know who receives this what salary. So which means that to answer the first question, we'll say what? Select minimum, right? Salary from employees. That's the statement, right? Then the next statement will be that who now receives the salary. So we say select all from employees where salary is what is equals to maybe this result gave us 5,000, right? So we now say where salary equals 5,000. So with this, we're able to know who receives the least salary, right? But this will mean that we have to write two statements, two different statements. This one first and this one second, right? So why do we have to write two different statements where we can write both statements in one statement? Right? We can answer both statements in one statement, right? So what do? If you look at the way these statements are being arranged, right? Of course, this was executed first. That this number one statement was executed first. And why? We needed to know the least salary, right? And that the second statement used the result from the first one, from the first statement. Use the result from the first statement. So if that's the case, I know that I can then proceed to say that, okay, instead of saying writing two statements, I can combine both statements and say select all from what? From employees, right? Where salary is equals to select minimum salary from what? From employees. Right? So if you look at it, what did I just do? I put the first statement inside the second statement. It's as easy as that. Right? But where? In the where clause. Right? I put it in the where clause of my select statement. Right? So what does that mean? It means that how does this now get evaluated? That's the question you want to ask yourself. Please let me know if you understand the concept of what I just explained before I move further. Please let me know if you understood the concept of what I just explained. A query inside a query. Hello, people. Hello.
Hello, sir.
Yes, I can hear you.
So, in this case, the subquery is going to be the selecting salary, the minimum salary, yeah?
Yes, that's the subquery.
That is subquery. While the main query is the select all from employee.
Exactly. So this is the inner query, and this is the outer query or the main query. I've said that before. This is your subquery. This part is your subquery or inner query, and this is your outer query or main what? Main query. So the subquery supplies results to the main query. The result of the subquery is what the main query uses. Right? So if it returns X, then this statement now becomes select all from employees where salary equals what? Equals X. Are we there? I need people to answer me. I want to finish the query in under 20 minutes. So please answer me. Vivian, Lola, John, do you understand what I just explained? The concept of subquery before we move it further.
Yes, I understand.
Okay. Vivian.
So I don't, but just go ahead. I'll probably listen again from the record.
All right. Lola.
Yes.
Do you understand it?
Yeah, I saw again, but I'll go back. But yeah, I got it actually.
All right. All right. So um so if you look at it, so we said that we want to we want to know, the question is who receives what, the least salary in the company, right? Who receives the least salary in the company? That's the question. And I said that we have to know two things to be able to answer that question. We know the first thing we need to know is who receives, what is the least salary. That's the first thing we want to know. What is the least salary? Then when we know what the least salary is, then we can what, now find out who receives the least salary. So basically, it's like you are pruning, or you are probing. Sorry, not pruning. You are probing for an answer to a question with a clue. Yeah, that's the word. With a clue, right? So I want to know who's I want to know who is in the same department with Lola, right? I want to know who are the people in the same department with Lola, right? But question is, what department is Lola herself? Before I know those who are in our same department. So the clue that I need to know, or the first thing that I need to know is to identify, right, Lola's department. Once I know Lola's department, then I'm able to get the people in our department, right? So if I say um it's just you getting a clue from another kind of data to search out a kind of data. That's basically what subqueries are all about, right? So let's go back to SQL to run that statement that we just talked about, right? So our first business case for that is uh, generate a report of those of who earns the least salary in the company, right? So to do that, we use a subquery. So we say select minimum salary from employees where what? Where salary is equals to, sorry, select all, not minimum now. Select all. Where salary equals select minimum salary from employees right? So if we run the statement, hold on.
The where is there not supposed to be something before it?
Yeah,
Where
that's what
salary?
the salary.
Okay.
Sorry, thank you. Sorry, not start of our database. Right, can you see? So basically, this select minimum salary from employees actually brought us 21,000 or 2,100, right? Brought us 2,100 as the result. So that result is now used as in the what? In the where clause to say where salary equals what? 21,000, I mean 2,100. So you can see how a subquery works, right? It's basic, it's as simple as that. Right? It's as simple as that. Let's look at another statement or another business case. Generate a report of those who earn more than Abel. Can you see? Want to know those who earn more than Abel. That is the main question, right? That's the main question. But the subquery question will be that what is Abel's salary? Right? If we know Abel's salary, then we're able to use that information on that data to fine tune or get out the reports that we need. So the question will be that how do we get that? So we need to first of all know Abel's salary. Once we know Abel's salary, then we can answer for those who would earn more than Abel. So select first name, last name, job ID, salary from employees. Where salary is greater than, who earn more, right? So how do we know Abel's salary? So we say select salary from employees where last name equals what? Abel, right? And what does that do, right? That would return to us Abel's salary. And with that result, we're able to say where salary is greater than what? That result, right? So if we run this statement, right, it will tell us all those who earn more than Abel. Right? Can you see? These people, all these people earn more than Abel. All these people earn more than Abel. Right? So you can see that we used an information that we know, right? As tiny and as flimsy as it can be, it is what we use to search out more data, right? So first of all, the subquery executes. Now, how does the DBMS execute initially? Right, it executes the subquery, right, first, and what insert its result in front of the comparison operator that is used, or in presence of the operator that is used in the main query or in the outer query. Right. So in this case, the operator here is what's greater than. So this result here, this one here, would give us a particular value, and that value is used to compare to see if those who earn greater can earn greater than that particular value. Right. It's as simple as that. Right. It's as simple as that. Right. So we can now begin to look at single row subqueries and multiple row subqueries, right? So which means that some subqueries will return a single row, some subqueries will return multiple row, right? Some subqueries will return single row, some subqueries will return multiple rows. Hold on, please. Hold on, people. I'm just give me a minute, please. Hold on. All right. So sorry, I'm back. So we want to look at single rows of query and multiple rows of query, right? Basically, and that will be all for subquery. Subquery is a very short topic, so you don't need to spend plenty time on it, right? So we want to talk about single row operators in subquery. Sorry, single row operators in subquery and multiple row operators in subquery, right? So we remember that our single row operators are operators that allows us to compare values against one single value, right? We compare a single value, right? So we say greater than, less than, less than and greater than, less than or equals to, greater than or equals to, not equals to, and equals to, right? Right. And then when we talk about multiple row operators, we have in, we have any, and we have all, right? So let us look at examples of how these guys work. Let's see an example. of how these guys work, right? So a single row subquery, it says generate a report of those who are in the same department as or as Lex, sorry. Generate a report of those who are in the same department as Lex. And what does that mean? The question that we want to answer is that who are in the same department with Lex? But the underlying question that would help us get these answers or answer to this question is that what exactly is the department of Lex, right? So that will be our subquery, right? So in this situation, what that means is that Lex cannot be in two departments. So it's probably going to be in one single department, in a single department, right? If Lex is in a single department, then it means that the statement that will get department out would give us a single result. If it gives us a single result, then what do? We are going to use in the main query, use a single row operator to what? To use to work on that result. It's as basic as that. So we say select first name, last name, department ID from employees, where department ID equals, can you see? Select department ID from employees, where what? Where first name equals what? Lex, right? So first name equals Lex is going to give us select department ID from employees where first name equals Lex is going to give us Lex department, right? Which is a single value. Therefore, because it's a single value, then department ID can now be equals to that single value because we use equal to. Equal to is a single row operator, right? We use it to compare one single value to work on one single value, and that's as basic as that. So if we run this now, right, what do we have? Right? So it's telling us that Lex is what? Lex is in department 90. Can you see? Lex is in department 90. And these are all the people that they share departments together. I hope you understand. I hope you understand. Right? So it is not a hard thing, right? So once we look at multiple rows of query, it says, well, we're looking at this business case, generate a report of employees that earn the same salary as the minimum salary of each department. Can you see? Can you see? I want somebody to interpret this to me using subquery, right? I want somebody to interpret this to me using subquery. Generate the report of all employees that earn the same salary as the minimum salary of each department. You don't need to write the statement. Just explain what you think that question is saying to me. Anybody? Anybody? I'm waiting, please. People, please try now. Lola, John, Anu, IBK. Come on, guys. All right. Since nobody wants to volunteer, I'm going to go ahead so that we don't waste time. Right. So, generate a report of.
So
Huh? Yes,
yeah,
somebody.
let's try.
Yes, yes.
So he's saying that we should generate a report of all employees that earn the same salary as the minimum salary of each department. So he's saying
Mhm.
from each department we are supposed to collect the list of employees that earn the same, that have the same salary. So there is a minimum salary from each department. So he's saying, okay, bring all the employees that have the same salary, which is the minimum salary, together.
You are getting it, but you are mixing it up. Say it well again, please.
So for each department,
Mm-hmm.
there is a minimum salary that is in each department.
Okay.
So the statement is saying we should generate the list of the employees that earn that particular salary from each department. So it's like for each department, the minimum salary might be different. So saying with respect to each department, we should generate the list of employees that earn the salary, which is the minimum salary.
All right. Nice try. Well done. Right? So, well done, IBK. So this question is basically saying that, or this business case is basically saying that we should generate a report of all employees that earn the same salary as the minimum salary of each department, right? So if you look at it, it is not specific to, as much as we want to get. So the first question is, what is the minimum salary of each department, right? If we know the minimum salary of each department, right, we'll now use that value, right? Those values. Now, if you look at it, the minimum salary of each department cannot be one single value. So it's a range of values because we have to group by department. So when we group by department, it's going to give us individual minimum values for each department. Then we now use that value to search out every employee that either earn any of those values, right? And that is basically what that question is saying. So look at it. So the minimum salary of, can you see the minimum salary? So we are saying the subquery is, the first question we want to ask is, what is the minimum salary for each department, right? So how do we write a statement for that? So it says select minimum salary from employees, right? Select minimum salary from employees, group by department ID, right? Group by department ID. So we group that by department ID. We group each of those departments by department ID, right? Now, once we get the result by department ID, now we now say that those who what and any what any of those salaries, at least those who earn what the same salary as the minimum salary. So we now say that select what all employees that earn salary in any of these values, right? So which means that this inner query is going to give us multiple results, and because it's giving us multiple results, we are using the in to be able to what to look through each of those results to see if there's anybody who earns that amount of salary, right? So it's as basic as that. So if we run that, can you see? Can you see each? These are the results from each of those, right? So the minimum salary is of department is 17,000, some is 6,000, some is 4,200, some is 6,900, some is 2,500, some is 6,500, and so on and so forth. So these are the people who earn between the what? Maybe the lower value there is 2,000. The lowest value there is 2001, and the highest value there is what? 17,000, right? So that is how it works. But it's not in a between. This is not a between statement. This is that it's going to compare, right? All those values. It's going to compare those values using what? Using the in what? The in condition. So all those values are put as a set, and it begins to iterate over each one of them to see if it finds any employees that earn that amount of salary, right? It's as basic as that. It's as basic as that, right? So that statement that you just saw, yes.
I wanted to ask this in statement.
I can hear you.
Can we use the equal to sign to also be to mean the same thing?
No. The reason is because in is expecting multiple values. Let's do something, right? If I remove this in now and I slot in equals to, right? Let's see if it's going to run. It's going to give you an error. It says subquery returns. Can you see the error? I mean, the error there. Subquery returns more than one row. That's the error it gave us. So it's saying that the subquery returns more than one row. Therefore, equals to cannot work there. Therefore, that's why we use in.
So the in statement is when we are expecting multiple values from a particular statement.
Yes, we use the in, not just in subqueries. In subqueries, right? Even in our singular SQL query, we use in when we are checking values from multiple when we're checking multiple values, we use in, right? We use in to check
All right,
for
sir.
multiple values, right? So if you run that again now, you see that it's a run, right? So basically, what you are saying that this statement, right? Select minimum salary from employees, group by department ID, which is the subquery. This is the result that it gave. Can you see? It gave you 7,000, 4,400, 6,000, 2,500, 6 times 6, 5, 6,500, 2,100, 4,200, 10,000, 6,100, 17,000, 6,900, and 8,300, right? So you're now saying that you want to look through each of these values, right? So what you need to do is use the in function or the in operator to iterate over each of these values. That's basically what you're doing. So this statement here and this statement that we ran, which is the subquery, are the same statement, right? Except that we didn't know these values, right? But we use subqueries to get out those values, right? And those values are now supplied to us to the inner query, I mean to the outer query or the main query. So this statement is exactly as what you have up there, right? Right. So now another way to work with this is to use, so we've used the what, one of the multiple row operator in, right? We've used one of the multiple row operator in, right? Now we want to use another multiple row operator, which is the any. Can you see? We've talked about the any before, right? And I've told you SQL is fashioned against English language. So from that you have, what you are saying is that we want to know if there is any employee, same statement, same business case, except that we want to know if there is any the employee that earn salary that is in the what, that is equals to the minimum salary from each department. So yeah, instead of using in, we're using what, any, right? So we use any, of course, it equals to any of these values, any of the values returned from the SQL subquery statement. That is what you're saying. So if you run this, it will give you a result of any, right? If you look at it, they gave the same results, 26 rows, because they are the same query. So you either use in or you use any, right? Either you use in or you use any, right? So now same statement, right? Want to know who are those that receives um greater than, can you see, where salary is less than all, right? Those who receive less than the result that is returned from the subquery, right? So those who receive more than who receives less than the result from that subquery, right? If you run that, you see that there are nobody who receives lesser than that. That is, of course, we know that the lowest person, the lowest salary that you can earn in this database or in this company is 2,100. So if you are saying lower than, that is lesser than all, right? It means that you must be able to provide, or you must have provided a value that is lesser than the minimum salaries, right? So these are ways to use these multiple single row and multiple row operators in the subquery, right? It's as easy as that. So basically what we have done is that we have looked at subqueries and we have been able to explain subquery to its peak, right? There is nothing left that you need to know about subquery that you don't know. So now you can work with subqueries, right? You want to answer a question. Um, um, you want to say that I don't want to eat. I don't want to eat what I ate last night, right? I don't want to eat what I ate last night as dinner or as breakfast. I don't want to eat what I ate last night as breakfast. So the question will be that, what did you eat last night, right? So once we know what you eat last night, then we can exclude it from what? From the list of foods that we have available. So that's basically how the subquery works, right? We use a value to probe out a certain search of or a certain kinds of value that we're looking for, right? Please let me know if you understand it better now. Now, we also want to go to a more a very simple topic as well. This is chapter 11. And after this chapter, we have just one more chapter to go. I'm hoping that we can finish today. I'm really hoping that we can finish up today. Of course, we can actually finish. What we have left is less than an hour of class, actually. That's basically what we have left. Less than an hour of class, because what we want to talk about now is data manipulation language in chapter 11, right? Right? And what we want to talk about is data manipulation language, right? So when we talk about data manipulation language, usually I left it for last, right? If you look at several literatures that deals with several SQL literatures, right? This is the topic that comes after select statements. But because this training is geared towards making us ready for opportunities and ready for work, right? Discover that data manipulation is not as technical as people made it look like, right? And there's no need to spend most of our time talking about it when we have more important topics or more important part of SQL to talk about, which we have covered of DML and all of that, right? So basically, we want to talk about. Remember that we have created tables. We have created tables. We have altered. We have created tables. We have dropped. We have used DML statements. But basically, we talked about tables, and we said tables are that container. They are the virtual containers or the logical containers where we store our data, right? Right. That's basically to say tables are a basic storage unit for data, right? And once we have created these tables, we need to be able to learn how to insert values or how to update values or how to delete values from those tables, right? So that is where DML comes in, right? And we've talked about the select statement, which allows us to read data from a table. Now we want to look at how to really manipulate data in a table. And there are just three ways to manipulate data in a table. We use the insert statement, we use the update, the insert, the update, and of course, the delete, right? The insert, the update, and the delete. Oracle SQL has what we call the merge. Merge would do either in insert or update, right? It does insert and update together. That is, if the value does exist, update it. If it does not exist, insert it. That's visible. But that's only in what's it called, Oracle SQL, right? It is not an SQL language or general SQL language. It's only developed by Oracle, right? So we want to talk about the first one, which is the insert. From the word insert, it is English language. When you say you insert something, you're putting something into, right? So we want to insert. We use the insert, or insert is used to put records into a table, basically, right? Simple. They are used to put records into a table.
That's populating the table.
Yes, populating the table.
Okay.
So we use insert to populate the table. So when you want to, after you have created the table and you want to insert data into the table, or you want to populate your table, as you have used Pi English to say it, we say we insert the values into the table. So yes, we populate the table. Let me use your English now. We populate the table, right? We populate the table. Right? So we use insert to populate or to put records in the table. Now we use the update to what? To change records in the table. That is, the record already exists, right? You want to change it. So what kind of record are we talking about? So this person got a promotion from stock clerk to stock manager, right? So we change the person's job ID from stock clerk to stock manager. This person got a promotion from assistant admin to admin or to supervisor admin, right? So you want to update the person's what details on the database, right? Or the person's salary was reviewed at the end of the year, and from 5,000 the person begins to earn will be earning 7,000. So you want to also update that. So we use the update statement to update. Then of course we use the delete to delete records from a table. So when you want to delete a record from a table, we use the delete statement, right? All right, so hold on. All right, so we want to use, I'm going to take a break. We're going to take a break from HR. We want to use a schema called Avita that I have here. I'm going to run Avita, right? And inside Avita, now look at it. This is a create table statement for those of us who have forgotten what a create table statement looks like. This is a create table statement, right? Yeah, what are we doing? Create table. The name of the table is student. The name of the table is student, right? Right. So the name of the table is student. So we're saying matric number, init not null, primary key, first name, voucher 25 not null, surname, voucher 30 not null, phone number, init not null, email, init not null, course, voucher, email, voucher not 30 not null, email, voucher 30 not null. Then department, right? Voucher 25 not null. So if I run this now, I will be creating a table in my Apita database, right? So if I reload this now, if I reload this and I check here, you see that we have a table called student already, which was not there before, right? Now, so we can describe the table, which we will not do. We say select all from students table, right? You discover that the table is empty, right? Can you see? Nothing is inside that table. So we want to insert values into that table. How do we insert values into the table? It's simple, very simple. We use the insert into clause, right? Insert into the name of the table, right? So to insert into a table, right? So to insert into a table, use insert into table underscore name, right? Then you do a column list. Are you there? And then you say values. Then you specify all the values, right? This is as simple as this. You see, life is not hard. It's as simple as this. Insert into tables, the name of the table, then a column list and values for all the columns that you have listed. So let's see a practical example of that, right? Insert into tables, student. Can you see? The student, remember, look at the student table here. The student has matric number, has first name, has surname, has phone number, has email, has not null. I mean, has course and not null. So if we describe that table, you'll discover that most of the columns there are not null. Let's describe it, right? So which means that they must have values, right? Can you see? Not null, not null, not null. And it's no. Can you see? No, no. So all the tables need values. All the columns, sorry, need values. So what do? We say insert into student. Are you following me? Then we begin to specify all the column names of the tables. The matric number, the first name, the surname, the phone number, the email address, the course, and the department. Then we say values, right? So then we now begin to give each of the columns of values. Matric number is 100, first name is Oluwaseun, last surname is Akintibubo. Phone number is 35353. Email address is shown always at avita.com. Course is biochemistry. Department is FBMS, right? So if we run this now, if we run this statement, sorry, I have blocked nose. That's why my. So if we run this now, right? It will tell you that one row was inserted, one row inserted. So if I run select all from student, what do we have? Select all from student, what do we have? Can you see the table that was empty before now has data, right? The table that was empty before now has data. Now, do not forget, remember that I've said it before that all DDL statements, right? DDL is data definition language. That is to create your alter, your drop, your rename, your comment, and your truncate, right? All of those are auto commits. That is when you perform a transaction with those statements, they are automatically saved, right? That they are auto committed statements. But DML statements are not auto committed. You have to commit them. What does that mean? It means that these values that we've inserted, right, is still not permanent. Are you following me? These values are not permanent. If I roll back now, what happens? That change is undone. So if we run all from students, usually, I'm not sure it's going to work, right? Basically, that's one of the advantages of MySQL, databases like MySQL, right? Once you perform something, is as good as auto commit, right? But in the real structure, these values that we've just, or these values that we just created inside the employee, I mean inside the student table, are not permanent yet, right? Because we have to commit them. We'll talk about commit and rollback later. We have to commit them. We have to commit them, right? So we have added a single row. Can you see a single row? 100 Oluwaseun, blah 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 to our table. Let's add one more, right? Now, we want to add one more. Now, in this situation, because we know that all the data, all the column in the table needs values, right? What does that mean? It means that I do not need to specify the names of the columns anymore if I'm going to be giving all of them values, right? So I'm saying insert into students. Can you see in the initial example, I opened a bracket and I named all the columns, right? But in these other examples, I just said insert into student, and values, right? I just put values straight. Just put values straight. 100 Olalikon Joshua 45336 OJ at avita.com, computer science and sciences, right? So if we run this now, what do we have? We have coming. Right? So if we run select all from student again, you see that we have two rows already. Can you see? Two rows, 100, 101, and all of that. So can you see? It's as simple as that. You're populating the table already. So because the table now has data, I can now begin to write projections and perform selections against the table, right? Look at it. Select. Hold on, please. All right, so we can now begin to write select statement against that table, right? We can begin to write select statement against that table. See, select matric number, first name, surname, department from student, where matric number equals 101. If we run that, it's called that it just brings Olalikon. Can you see? So basically, it is not rocket science, right? So that is how to insert. That is how to insert. That is how to insert. Please let me know if you understood insert. Let me know. Let me know if you understood insert. Please let me know if you understood insert. Anybody? So quiet in this class. What happened? Anybody, please? Do you understand all that we have talked about?
Yes, I understand.
All right, Trisha. Any other person? Vivian, Lola, John, IBK, and Oluwapo. Do we understand?
Yeah, I understand what you explained.
All right. All right. Don't worry. We're almost done with this training. So I'm sure. Don't worry, we'll talk about all of that later. Right. So any other person? Lola, do you understand? IBK, do you understand? I know I've not heard from you. Do you understand? All right, so that basically is insert, right? That basically is insert. So you can insert values, right? Now look at it. It's a DDL. For DDL, we work on structure of the table. That is, when you talk about DDL works on the structure of the table, while DML works with the content of the table, right? DDL works with the content of the table. All right, so let's go back to that table. I just want to stay on this table, right? This table that we're using. Just want to stay on it, right? So we have inserted, right? We have inserted, right? Now let's assume that so we have inserted values in the table, right? So the business case that I want to look at now is that, so I want to talk about update statement. Update statement, right? Now, update is used to change values in the database. Used to change values in a table, right? That's update statement. So the business case is that okay, the student um 101, sorry, the student with matric number 100 has changed course from biochemistry to medicine, right? So update the table accordingly, right? So the student with the matric number 100 has changed course from biochemistry to medicine. Update the table accordingly. So what do we do? The first thing you want to do is to confirm, right? What is the present state of the data, right? What is the present state of the data? So you want to say select what? Course from student where matric underscore number equals 100, right? So if we run this, you will see the course, right? So his course is biochemistry, right? And they said he has changed from biochemistry to what? To medicine. So how do we update? You see, update students. That's the name of the table. So we're updating the students table, right? Update student, right? Set course equals medicine, right? Set course equals medicine. Where now, if you omit the where clause, are you following me? If you omit the where clause, it's going to update all the rows, right? Let's try it. So let me show you. If we omit the where clause, it's going to update all the rows. So if we run this now, right? It's a, can you see? Now MySQL has a situation, or has a, we call it safe mode, right? In MySQL, that prevents us from making terrible mistake on the database. If it was Oracle, this statement will run and you would have problem, right? Or even in MySQL, in Microsoft SQL, it will run and you would have problem. But this is one of the few advantages of MySQL. It will prevent you from making terrible mistakes. And because it is an update statement, it was expecting a where clause. That is why it gave an error. Can you see? It says error code 1175. You are using safe mode update mode. You are using safe update mode. Hold on. You're using safe mode update mode, and you try to update a table without a where that uses key functions, right? So what does that mean? It means that it is expecting us to put a where clause. So, but if this ran, what that means is that if the statement had run, right, or executed, it will change the course of both students to medicine, which is an error, right? So yeah, without say, to make it specific, we say where what, where, who are we changing it for? Where matric underscore number equals what? 100, right? So if we run this now, that's been updated for that person, right? So if we go back and say select all from student where matric underscore number equals 100, right? If we run this statement now, what do you have? You see that medicine, it has been changed to medicine from biochemistry. Its course has been changed to what? To medicine. That means that we have updated his what? We have updated his course, right? So that is how to update. Are you following me, please? Please let me know if you're following me. Let me know if you're following me.
Yes, sir.
All right. So another business case, it says the student with the matric number 100 or 101 has changed his phone number to 0231234 blah blah blah, right? Update accordingly, right? So what do we do? Right, an update statement. First thing is you confirm, select phone number from student where matric underscore number equals 101, right? So here we confirm, right? Look at his phone number here, but he said he has changed what? He has changed undo. They said he has changed that phone number. So what do? We update. So this time around, update student, set phone number to what? What phone number did they give us? Set phone number to this phone number. So we copy this, we paste it here, right? Set phone number to that. Where student matric, where matric number equals what? 101. So if we run this now, what do we have? It says that one role has been changed. So if we run select phone number again, right? Select matric number. Right? Can you see his phone number as what has changed? Right? So that is how to update a record. That is how to update a record. That is how to update record in the table. Right? Now, come in. All right. All right. So that is how to update records. That's how to update records. Now, we want to look at situation. So let's look at another business case before we move to the last part of that, which is delete, right? Um, the please update. Okay, let's write a proper business case. The school authority has decided to keep to add a new variable guardian to the student table. Please update the table accordingly with the data gotten from the students. Right? So the school authority has decided to add a new variable called guardian to the student table. Please update the table accordingly to um, please update the table accordingly with the data gotten from the student. So how do we solve this? Who will tell me? How do we solve this? How do we solve this? Who will tell me? Anybody? How do we solve this? How do we solve this, please? Nobody is answering me. Hey. All right. Are we there? Are we there?
So I'm not even seeing the entire question. That's why.
This is the entire question. This is the entire question. See it, you. The school authority has decided to add a new variable guardian to the student table, right? Please update the table accordingly with the data gotten from the student, right? So you want to first of all confirm from the table if there's any column called guardian, right? So when you hear the word variable, it means column, right? It means column, right? So you want to confirm, is there any column called guardian? So you describe the table and you saw that, oh, there's no guardian. There is no guardian there. So what do we do? How do we adjust structure of a table? We use the alter table, student, right? Add column. What's the name of the column? Guardian, right? Varchar what? 25 or varchar 40, right? What's the constraint? Not none. They must have a guardian, right? Every student must have guardian. So if we run this, statement now, that table has been adjusted. If you describe students again, you will see that what? There is a guardian column. Can you see? That's the guardian column. So if you say now you want to query the table to see how it looks, select all from student. Select all from student. Right. Can you see? This is, but if you look at them, both of them have missing values in their guardian. Can you see? Both of them have missing values in their guardian column. Right. So now we want to update. So they said the student that provided a record, right, that we want to use to update that guardian column. So what do? We now begin to update student, set guardian equals Mr. Akin, where matric underscore number equals what? 100. Right? That is, we're setting guardian for the person with matric 100. We're setting his guardian to be equals to Mr. Akin, right? So if we run this statement, what do we have? Right? It says it has been done. So if we run this, select all from, can you see, Mr. Akin is now that guardian, that person's guardian, right? So if we copy this statement and we do for the second person, right? 101, his own guardian is Mrs. Ben. Yeah, Mrs. Ben, right? And we run that, right? That has been executed. So we select all from the student again. Can you see? Both of them now have guardians, right? It's as simple as that. Isn't that beautiful? It's as simple as that. It's as simple as that. It is as simple as that. Any question, please? Any question? All right. So that is that. Um,
Sorry, I have one other question.
okay.
Okay, I could see that you first of all altered table,
Yep.
right? You defined it. I think, yeah, you gave it the varchar and the constraints and the rest. Then
Yes.
before you now updated the table, is there like a language, like is it possible for you to do it like in a straight up language, like in a, how do I put it? I don't even know how to explain, like instead of
Do
doing
both all of
like
them
doing
together.
straight up, yes, like
No,
doing
you
it straight
cannot
up
do it.
in a different way.
No, there are
Oh,
two different things that you are trying to do. First of all, this statement here is to alter the structure of the table. This is a DDL statement, right? This is a DDL statement. We use this one to alter the structure of the table. This increased the size of the table. That's what we're saying. It increased the size of the table. We added a new column to the tables. The table had 6 columns before, but now it has 7 columns because we've added another column to it, right? So that is a different case scenario. Then, having done that, we now begin to use DML statements to fill up the new columns, right? We use DML statements to fill up the new column. So there are two different kind of statements that cannot be done together. I hope I answered the question.
yes, sir. Thank you very much.
Awesome. Awesome. All right. Trying to see what we need to do again. All right. So basically, we have done insert and update. We have done insert and update. We've done insert and update. So the last thing we want to do now is to delete, right? We want to delete. Want to delete data, right? We want to delete data, right? So the next thing we want to talk about is deleting data from a table, right? So we use the delete what? Use the delete statement. Right? Using the delete statement. Right. So how do we delete from a table? It's as simple as it is. Delete from table. What's the name of table? Delete from student. Right? Delete from student. Where student, sorry, where okay, delete from student where, let's use guardian now. That's what we know about the question. Delete from student where guardian equals Mr. Akin. Right? So we're saying delete from student where guardian equals Mr. Akin. Now, the reason why this will not work is because we did not use a, hold on, just give me a minute. All right. So yes. So when you want to delete from a table, right, you use the primary key column to do that, right? The first statement that I ran did not work because I was using a non-key column to delete, right? So that is why that did not work. So you use the primary key column to delete, right? So where in your where clause, of course, you have to add a where clause. If you do not add a where clause, right? If you omit this part, and you just say delete from student, what happens? All the rows will be deleted. All the rows will be deleted with this statement. So you have to add will be deleted if you omit the where clause. Right? So if you omit the where clause, all the rows will be deleted. So therefore, you have to add a where clause. So you have to add a where clause to it. You have to add a where clause to it. Are you following me? You have to add a where clause to it. So if we delete now, so I've run this now. So if I say select all from student, right? What do you have? Discover that what you have there is just one data. Remember, we had two of them before, right? So what you just have now is one data, right? So if I proceed to deleting this data again, then the table becomes what? Empty. Are you following me? So that is how delete work. It's as simple as that. So you can delete from any of the tables that you have, right? But you must have delete privilege. Now remember, all these things that we are doing on the tables, using DML, using DDL, and all of that, you must have the privilege on the table to be able to do all of these things. If you do not have the delete privilege or the insert privilege or the update privilege, you will not be able to do that. And I've told you that by default, because you are a root user, you have all the privileges on your database, right? That is why you are able to do everything on your database. But you probably get to an environment where you want to work, and your boss would have to, or the chief database administrator, or whoever is in charge of the database would have to give you privileges to work with, right? Give you privileges to work with. So that is how to work with a database. I mean, that is how to insert, update, and delete on a database. That is how to insert, update, and delete from a table. That's how to insert, update, and delete from a table. Now, the next thing I want to talk about, of course, is database transactions, right? What is a database transaction? So, want to talk about database transaction. Right. So from the word transaction, right? Remember that if you in finance, right? Or maybe banking and finance, if whatever you want to call it, right? You don't do a full transaction, or you do a full transaction when you credit your account, right? Or debit your account, right? So let me give you an example. If you go to the ATM machine, right? You go to the ATM machine to withdraw some money, right? What happens to your account? Of course, the ATM machine will give you some cash, right? Maybe you withdrew 5,000, right? 5,000 naira. The ATM machine would dispense 5,000 naira to you. That is, first of all, it has to check. So what it will do is that it will check your account to see that you have enough money to withdraw the amount that you want to withdraw. So basically, what it's saying is that select all or um, select balance from account table where account number equals this. So it will go into your table, into your data and see if you have enough balance. If you have enough balance, then it now continues the transaction and say, okay, this person wants to be debited 5,000, right? So what happens? They credit you 5,000 cash. The ATM will credit you 5,000 cash, right? 5K cash, but go to your account and debit you, right? It will credit you that cash, but it will deduct that what money from your bank account, right? It will deduct that money from your bank account. Why? Because there must be for every debit, for every credit, there must be a corresponding debit. For every credit, there must be a corresponding debit, right? Well, don't quote me on that, please. Right. So I'm not a financial person. I only do my own finances. Right. So in that case, what you say is that you have performed a full transaction. So imagine that you went to the ATM and you withdrew 50,000 and they did not deduct it from your account. You know that you still have that money. That's basically what it means. It means that even though they've given you the cash, right, but you still have that balance. So you can go back again and withdraw another 50,000, right? Because it means that you still have the money, right? So what it means is that for a full transaction to have occurred, there must be a credit from the ATM and there must be a debit from your account, right? Now we call this a full what? A full transaction. Now, bringing this idea to database to database, right? We say that you have performed a full transaction, a full database transaction. Remember, I was about to talk about database transaction now. Right? So we perform database transaction in two ways, either by performing a DDL statement and performing a DML statement, right? Whenever you make changes, whenever you do anything on the database with DDL statement, right? You are said to have performed a transaction, right? Whenever you do anything on the database with DDL, right, you have performed a transaction. You know why? DDL statements are auto-committed. DDL statements are auto-commit statements, right? That is, they are made permanent automatically. Auto-commit, right? DDL statements are what? Are auto-commit. So when you create a table, when you use the alter table statement, when you truncate, when you drop, when you comment, when you rename, it is automatically made permanent. Commit means make permanent. Commit means to make permanent, right? Like save in Microsoft, right? Like save, when you save a document, when you save your presentation, when you save your document in Microsoft, right? You say you have done a transaction, right? So that is the same thing that we're talking about. So when you do a DDL statement, when you perform DDL statement, what you have done is that what you say is that you have performed. Oh, okay. I was scared. I thought I didn't record, right? So when you perform the DDL statement, what you say is that you have performed a full transaction, right? Now, the next way to also make a DDL statement, I mean, to make a database transaction, is that you perform a DML statement. Remember, DML statement includes insert, update, and delete. Now, whenever you do any of this, either you insert, you update, or you delete, right? What you have done is half of the transaction, right? Anytime you perform an insert, an update, or a delete, right? You must commit these transactions, right? You must commit the transactions, right? To you must commit the transactions to have fulfilled, if that's a good English, to have fulfilled the criteria for a full transaction. Now, what does that mean? It means that when you perform, well, these are not really what happens on MySQL, but this is the general SQL statement that I'm explaining to you, right? In MySQL, what I've noticed is that insert, update, and delete are also auto commit, right? They're also auto commit. So, but in general SQL, you perform insert or update and delete, right? Any one of them. You have to commit the transaction, right? You have to commit. You have to issue a commit, right, for the transaction to be a full transaction. You have to sorry, you must commit or roll back. Sorry, I omitted roll back. You must commit or roll back, right? You must commit or roll back. So we have now what I'm explaining to you is actually the next part of SQL, which is called transactional or transaction control, TCL. Transaction control, TCL, right? And under transaction control, you have commit, you have rollback, and you have save point, right? You have commit, you have rollback, and we have what? Save point. So we are saying that when you issue a DML statement, right, they are not auto-committed, right? It's like you're working on Microsoft Microsoft Word. If you don't issue Control S, right, unless your system is set to auto-commit every 5 minutes or every 10 minutes, it will automatically commit it. But if you do not set your system to auto-commit, you have to manually save by using what? By issuing what? Or pressing Control S every time, right? So it's the same thing that we're doing here. So when you perform an insert, an update, or a delete statement, you must issue a commit at the end of it, right? So take for example, as we did commit, as we have been working with DML statements since now, right? Look at it. Now look at this. Let me explain something to you. So we started working with SQL statements here, right? We started working with SQL statements here. Okay, so right. So this one now, I've told you this create statement is auto-committed, right? It doesn't need a commit statement, right? Then we started inserting. So I inserted, then we inserted another value, then we selected again, then we updated, then we updated again, then we updated again. After the update, you see, after that update, I was supposed to issue a commit, right? Somewhere around there, say commit, just commit like this. That's all, right? I was supposed to issue this commit, but I did not issue that commit. Then we ran an alter table statement, right? You see this alter table statement, it committed, running this alter table statement, of course, this alter table is DDL, so it is auto commit. Now, what that means is that it will auto commit itself and it will automatically commit every transaction that I've done. Are you following me? This statement auto committed itself because it's auto commit, right? And alongside it committed all the statements, all the DML statements that I have done, right? So, but that is a very but it works actually, right? So everything that I've done here, which I was supposed to commit at the end of this statement or somewhere around here, that I did not commit, right? Issuing these DDL statement auto committed it for me, right? So all of those have been made permanent in the database, right? Then I issued another update statement, then I issued another update statement, right? Then we did another delete, and we did another delete, right? After here, right? After this now, I'm supposed to what? After confirming it, then I say commit. Right? If I issue this commit and I run this commit, everything that we've done has been made permanent. That is basically what it means, right? But you must, before you commit a transaction, so commit means that you are making permanent or you are saving, right? You must make sure that what? The transactions are free of errors. Because if you commit them with errors, it means that you have made error permanent on your database as well. So before you commit a transaction, that's why if you look at it, for every time that I perform a transaction, after I have performed the transaction, I would go and check to see how it looks like with the select statement, right? So that I see it did it work the way I wanted to work or not, right? After that, then I issue the commit, right? So that is how to perform a commit. Now, if there is an error in your transaction, if there was an error in your transaction, instead of issuing a commit, right? You issue what we call a rollback. Now, consider commit as control save in my SQL in Microsoft Word, control save, control S, right? Consider commit as control S and consider rollback as undo. So when you roll back your transaction, what it means is that you undo the transaction, meaning that there is an error in that transaction, right? So when you see an error in your transaction, what do? You roll back. You don't commit it. Once you commit it, you cannot roll back anymore. Once you commit, you cannot roll back. Once you commit,
So,
you
sir, I
cannot
have
roll
a
back.
question.
Okay, please go ahead.
So since DML statements are auto commit,
DMS
why would
statements
you
are
want
not
to
auto commit. DDL are auto commit.
DDL?
Uh-huh.
Yeah, sorry. Since DDL statements are auto commit, why would anyone want to commit them again?
No, you don't commit DDL statement. What you are committing is DML statement. What I said earlier is that after doing plenty DML statement and I issued a DDL statement, that DDL statement is auto committed. It committed itself and it committed all the DML statements that I've done earlier. Do you understand what I'm saying?
Okay, so at at what point do you now need to commit?
When you commit, when you update a statement, when you use the update statement or the insert statement or the delete statement, and you have made sure that it is error free, you commit the transaction. If it has
Okay.
errors, you roll back. If it has errors, you roll back. If it is okay, you commit it. So this is it.
Okay, sir.
Imagine that you are working, imagine that you've been working, you will resume to work as a database administrator or an SQL developer 9 o'clock, and you worked and your system is not on auto save or something, and you've been writing SQL from morning till night. You've been doing insert, update, delete from morning till 4 o'clock, and you did not issue a commit, and you mistakenly, maybe your system mistakenly went off. It means that you have not done anything that day. Because what happens is that the background processes would undo all the changes that you have made that have not been made permanent on the database. It will undo all the changes by itself. When your system is starting up again, it will undo all the changes, which means that you would lose everything that you have done. It's like you're working on Microsoft Word or Microsoft PowerPoint or Microsoft Excel, right? And you are not saving your document, and something happens to your to that system, right? What happens? You would lose the data that you're working on. You would lose the document that you're creating, right? That's why you save the document with a name and you put it in a location, right? So it's the same thing that happens in databases. When you're working on a database, you have to commit periodically. If you do not commit periodically, right, if you don't commit periodically, right, what you will do is that you are risking losing those transactions that you have performed. Do you understand? So you work a little bit, you check everything that you have done, you commit it. You work a little bit, you check, you commit periodically. When you notice that there is an error in what you have done, in the statement that you have done, what you do is you roll back. So imagine that I've run 5 statements and I run another 15 statements. And in between the 5th statement and the 9th statement, there was an error. What happens is that if I roll back all the transactions that I've done from 5 to 10 to 15, right, they are all lost. Are you following me? Right? Let me explain that again so that you understand what I'm saying. Right? Let's assume that I did so let's assume that I resumed 9 a.m. right? And I did 100 insert statements. Right? And I finished that at 11 a.m., 9 to 11 a.m. Right? 100 insert statements. Then at 11, I started to 12 a.m. or to 12 noon. I started doing some updates. update of about 75 rows, right? But I discovered that when I got to row number 25, right? Row number 25, there was an error, right? There was an error in row number 25, and I've done an extra 50. If I issue a row back now, right? If I issue a row back, remember that I did not commit this transaction, this one that I've done. I did not commit it. Are you following me? I did not commit that insert that I did. If I issue a row back, it will roll back to the beginning, which means that I will lose all of this. I will lose all of this. I will lose the first 25 that is good here. I will lose the what? The maybe 49 that is also good here. Are you following me? So rollback and commit are very tricky, right? Very tricky. So the best way to do it is that when you do a particular set of jobs, right? So let's say I started at 9 a.m. and I ran 100 what? Updates, right? Or 100 inserts. Let's say insert. Hundred inserts. After those 100 inserts, and I've checked. So the next thing is I check to see that they are what? Error what? Check error, right? To see that they are error free. Once they are error free, what do? I commit. Are you following me? You commit, right? When you maybe at 12 a.m. or at 12 noon, I'm doing some update, right? And I've done the first 25, and I discovered that on the 26th update there was an error, right? What do? I roll back, right? I roll back. What if I roll back now? It means that I'm rolling back all of these. It means that I have to start all over again, right? But I will be rolling back only the update part, not the whole transaction. Because remember that I have committed this part, right? I will be rolling back only what I've done from this part to this part, right? Not the whole transaction. That's why commit is important. Do you understand what I'm saying? Because errors can come in between, right? And when error come in between and you have not committed, if you roll back, you are rolling back everything that you have done. It's as simple as that.
Well,
Right?
sir, so there's no way that you can do anything to just go back to the 25 instead of the whole of 25 um deleting, like
No,
rolling back.
no.
Wow.
There is nothing you can do, right? Usually. Although we can now, it now depends on the technology you are using, though, right? It depends on the database technology that you are using, right? In Oracle, you can now begin to use flashback, transactional query, flashback, plenty flashback statements to now begin to maybe do a few things, but in MySQL, no, you have to start all over again. And even in Oracle, you still have to start all over again because you might not be able to get all of them. It's as simple as that. So that is why it is advised that you commit and roll back periodically. You do a few things, you check. Once you check, if it is good, you commit. If it is bad, you roll back so that you don't pile up your job and have to commit. If you commit everything, you are committing error. If you roll back, you are rolling back everything. No, you have to. Another thing that we do, or another function that we have, which does not, I've not seen work in MySQL, is save point. Save point. Consider save point as you are going on a 3-day journey, right? Save point is that consider save point as you started your journey at A and you're going to D, right? And you journeyed from A to B, right? Maybe you journeyed from Lagos. You are going from, I'm just trying to explain save point the best way, right? So you started a journey from Lagos, right? You're going to Kano, right? You're going to Kano, right? So you started from Lagos and you got to Ondo, right? And you decided to stop and take a rest. Are you following me? You decided to stop and take a rest. So you booked an hotel and you lodged in an hotel, right? and the next morning you continued. What you did there is that you created a safe point, right? Your stopping at Ondo is a safe point. What that means is that everything that you have done from from Lagos to Ondo is what is good, right? So you create a safe point and say that, okay, I will continue my transaction from here, or my journey from here tomorrow. So when you go to Kogi again, you lodge in another hotel, another safe point. When you create a new safe point, this safe point becomes invalid. I follow you. Because what the essence of safe point is that when you create a safe point, right? When you create a safe point, sorry, it's not invalid yet. Right? You create a safe point here. So you have you have Ondo, you booked an hotel, so there's safe point. Let's call this safe point 1, let's call this safe point 2. Right? So in Ondo, you have a safe point. In Kogi, you have a safe point. Then you continue your journey and you got to Abuja, right? ABJ. And you stopped again and you created a safe point 3, right? What that means is that safe point 1, at this point, safe point 1 is invalid, right? Because when you roll back, right, safe point now, when you now discover that, oh, I forgot something in, or maybe I forgot something in that's what kind of situation can take you back. Maybe you lost something, right? Maybe you lost your phone, you lost a document on the way, right? What that means is that you don't have to go all the way to Ondo anymore. What you need to do is go back to Kogi, right? Because what you are saying is that everything that you've done from Lagos to Kogi so far was good. Everything you did from Lagos to Kogi is good. So you are saying that you trust all that you have done from Lagos to Kogi, right? So, but the error happened between Kogi and Abuja. So what that means is that it's easier for you to go back to Kogi than to go back to Lagos or Ondo. Of course, Ondo does not exist there because you can only have 2 save points at a particular time, right? So when you go back to Kogi, what happens? This save point is cleared. So it means that you start your journey all over again from what? From Kogi, right? You start your journey all over again from Kogi, and you move on to make sure that no error occurred, right? So this time around, you stopped at Abuja, and there is what? So you say create a save point 3 again, and at that point, it is all good. Then the next morning, you move to what? To Kano, right? This same journey is what we have in SQL, right? You create save points when you have long transactions that you're trying to create. You are trying to update 1 million rows, right? 1 million rows. You're trying to update 1 million rows, right? And you start at 9 a.m. in the morning. That's your Lagos, right? And you did the first 100. When you did the first 100,000, right? You create a save point. What you do is that you check once it is good, you either commit or you create a save point, right? I usually do not create a save point. I just commit my transactions, then I move on, right? So, but you can create a save point. So I call that save point 1. When you move again, right? When you move again from 100,000 to 150K, right? You create a save point 2, maybe because you want to go and you want to go and take lunch, or you want to go and just chill a bit or rest a little bit, right? You take you create a save point 2. Now you have 2 save points. Then you came back again, you move from 150 to 300K, right? What happens? You create another save point 3. At this point, save point 1 is invalid, right? Because save point 1 is gone, right? Save point 1 is invalid. So what that means is that when you have an error in between 150K and 300K, right? And you want to roll back. What do you roll back to? You roll back to 150K and not 100K. Or in the beginning, 0, right? So that is the essence. This is the essence of save point. So in transactional queries, right, we have three components: commit, rollback, and save point. Please don't forget them, right? And how do we use them? Basically, we just use them by just calling them. There's no plenty SQL. So anytime you want to use a commit, you just issue a commit. It's as simple as that. It's commit, basic, and you run it. Commit, right? You commit, right? Anytime you issue a rollback, anytime you want to issue a rollback, you say rollback, right? You run your rollback, right? You issue your rollback, right? And when you want to create a save point, the save point A, right? Save point A. Can you see? So they are as simple as that, right? They are simple as that. They are as simple as that. Simple as that. No stress, no wahala. They are simple as that. Please let me know if you understood all that we have done today. Today we have done 2 chapters, and we have just 1 chapter to go, right? We have just 1 chapter to go, which is the sorry. We have data control. Data control. Yep. Yeah, we have administrative roles with grant and revoke. That's the last chapter that we have to study, right? So basically, what that means is that we have come to the end of SQL. Of course, we're going to do that last chapter, right? But so far, please let me know if you understood everything that we've done today. We've talked about, we started from joining. I explained a bit of what we did the last class in joining. So we're talking about joining. Then we moved to DML statement, right? We move from joining to DML statement. To subquery. We move from joining to subquery, then from subquery to DML statement. Insert, update, and delete. So please let me know if you have any question. Let me know if you have any question. Let me know if you have any question. Trisha, John, please unmute your mic and ask me if you have any question.
Okay,
I don't have any
sir.
question.
I have one for the rollback.
Okay.
In your explanation, you said whenever we issue a rollback, it takes us back to, I don't know, maybe like where you were saying
Let me show you
100,
something.
25.
Hold on. Let me show you
Okay.
something. Let me show you something. Right. So let's say that I say, let me copy this transaction. All right. No, let me copy this. Right. Let me copy this transaction. Right. Let me put it here. Right. So I was supposed to update this student and set the student's guardian name to Ben, Mrs. Ben. Right. But I sent it, instead of saying Mrs. Ben, I said Mrs. Zen. Right. Let's assume that what I put there is Zen. Right? And I run this transaction. Are you following me? If you run,
Yes.
if you check this table again, can you see that it is Mrs. Zen now? Can you see? But that is an error, right? That was an error. That is not what I wanted to do. So what do? That is an error. Then I have to what? Roll back, right? If I issue a rollback now this is where it is delicate. This is where it is delicate. This is the only transaction that I want to roll back. Are you following me? This is the only transaction that has an error. But I have issued 50 update statements earlier, right? I've issued 50 what? 50 update statements earlier before that statement. And I did not commit them. If I issue this rollback, they are all gone.
Okay.
Do you understand? If I issue that rollback, right? If I issue this rollback, all that good transaction that I've done before is gone. And that is why we say that you have to roll, you have to what? Do your transactional statement periodically. Once you do 5, you do 10, you do 20, depending on your capacity. You commit or you roll back. You commit or you roll back. So if you leave your job and pile it up and you roll back, man, you have no work that day. You have not done a job that day. Do you understand? So which means that now this kind of transaction, in this kind of situation, instead of me rolling back, right? Because I want to, because I know that if I roll back this transaction, right, it will affect all the transactions that I've done earlier. So what do? I will do it again. I will run this transaction again, right? I'll just copy it. And this time around, I'll paste it and correct that error. Then run that. So if you check student table again, you'll see that that transaction has been fixed. Can you see it is Ben again? Now that I've made that change, now that that change has been made, I don't need to roll back now. But sensibly, all I just need to do is use my sense to commit that transaction. If I commit it, it has been made permanent on the database. That's basically what it is.
Okay, sir. I
All right.
understand.
All right.
Thanks.
John, please talk to me. John,
I don't have
please
any
talk.
question.
Oh, you don't have any question. Awesome. All right. IBK, Anoluwapo, Lolade. Talk to me. All right. So, all right. In the absence of questions, right, we just have one chapter left to go. One chapter left to go. And that chapter is more of administrative role. It's more of administrative role. Now, what we learned in this training is how to use SQL, right? But there is the administrative part of databases, right? And this training does not cover that because that would make you a DBA, right? A database administrator, right? But that is not covered in this training. But I just want to give you an idea or an heads up on what that looks like, right? So that's why I added it to the curriculum, right? That's why I added it to the curriculum, right? Just want to show you what that looks like. I hope I have the code here. All right, so this transactional. All right, so this is the administrative role that I'm talking about, right? Administrative roles that I'm talking about. So in administrative roles, right, this is where we create users, create roles, create stuff that has to do with administering the database, right? And remember, I've told you that the database is a very vital component of every organization that needs to be well handled, right? What that means is that not just anybody should be allowed access to the database. And if you give somebody access to the database, the access has to be controlled, right? The access has to be, it has to be a metric monitored access, right? Such that you don't just open the database up to the same way you don't just open your house up to strangers. You don't just open your database to strangers, right? And remember, I've always said that everything that you want to do on the database, you have to have a privilege. You want to create a table, you want to insert, you want to select, you want to update, you want to delete, you want to truncate, you want to alter, you want to drop, you want to do anything on the database. You must have the privilege, the certain privileges that control that particular action. If you do not have that privilege, you would not be able to perform that action. Are you following me? Right. So we just want to see how some of these guys work, right? It's not a topic that we can discuss, right? Because how do I put it now? This training is not administrative in any way, right? This training is not administrative in any way. But I'm just going to show you a bit of it, right? So now if you look at it, we've been working with this schema side. Can you see my cursor, please? We've been working with this schema side since since the beginning of this training. We've been working with this schema side. But if you look at this other part, you see administrations, right? You see administrations. And other administrations, you see management and instance, right? And in this place, this is where the control and of course performance, right? And in this place is where you see the administrative part of the database, right? So in this place, you check the server status, your client connections, users and privileges, status and system variables, data export, data import and restore, instance startup and shutdown, server logs, option files of your server. You can see all from there. You can also come to you can come to server to come and see all of that. Can you see the same thing that you have there is what you have there? Performance, you can see the dashboard, you can see performance reports, you can see performance schema setup, management access settings, and so on and so forth. So I'm just going to show you a bit of it, right? It's not it's not an in-depth training because this training is not supposed to make you is a database administrator. This training is just to make you an SQL developer, right? So, but if you click on server status, this is what you see, right? And what does that mean? It gives you a full details of what is happening on your system. It gives you metrics and graphical details of what is happening on your system, right? So that is what you have in this place, right? So you can refresh. It's telling me that this service, can you see? It's saying that my service, my instance has been running for 2 days, right? This instance has been running for 2 days, right? See my CPU load, my connection, my traffic, key efficiencies, select per second. That is how much of select statement I'm running per second. Of course, the database is not an heavily used database, so that's why you have 000 in most of these things. And you have database, that is database read per seconds. How many select statements is being read from database per seconds? How many write is done per seconds? The buffer usage and all of that, right? Now, I'm not able to explain these things, but you see all these guys, they are vital information that DBAs must know, right? So we also want to look at client connections. What are the connections that I have? Can you see? All my connections are local hosts, right? The connections, so you can see thread connected. You can check the same metrics on your system, right? Thread connected is 4, thread running is 2, thread created is 4, thread caches, thread cached as is 0, rejection over limit is 0, errors, I have no errors, aborted sections, no, aborted clients, no, connection limit, that is if I get to 151 connections, it will terminate my connection, total connections 13, and you can see all details, right? All the details of what is happening. The connections that are sleeping, can you see this connection is sleeping? This connection is sleeping. This connection is querying. This connection is sleeping. These connections are system connections by themselves. These are daemon connections, right? Waiting, suspended, what they are doing, how they are performing, all of that you would see, right? Like I said, there's more explanation to all of these than meets the eye. Then we have users and privileges. If you want to create new users on the database, this is where you come to users and privileges. If you want to create new users, if I want to create a new account, say I want to add somebody into my database, right? I want to add maybe I want Vivian to be able to use this database, right? From home, right? I can just create a new user, Vivian. Can you see? What kind of, so that's the login name. Can you see login name, Vivian? Authentication type, standard, you have SHA-256 password, hashing _ SHA. Basically, those are password types. But just want to use standard passwords, right? Limits to host machines, leave that. Then I create a password for us. So I'll call the password Vivian. Right? So I create a password for her called Vivian. I create another, I confirm the password Vivian, right? Right, that's my password for her. So if I apply, can you see, if I come to this side, if I apply, the user will be created. Consider using password with, okay, so let's say Vivian 123, 123, Vivian 123, right? So expire password. Now let me explain this expire password. This expire password, if I click on it, means that that password should expire, right? What that means is that, remember that username and password are supposed to be, especially passwords, they're supposed to be private, right, to each user. So, which means that even the database administrator, the chief database administrator, this is the DBA, must not know your password, right? So when I create a generic password like Vivian 123 and Vivian 123, and I gave Vivian, who is a new user of my database, I say, Vivian, once you log into your database, you must change your password, right? Once you log into the database, you must change your password, right? After she has logged in and I saw that she has logged in and she did not, I have to expire that password. Can you see? It says password has expired. User must change password to use the account. Can you see? So that is what it's saying. So now I have to change the password for her, right? So what that means is that I've changed a password. Something is wrong with the password I'm giving. Hold on. Right. So if I apply this now,
So try
voila.
using capital letter and then
Don't worry.
that's cool.
I don't mind.
Okay.
Done.
Okay.
Right. So the user has been created, basically. Can you see Vivian? Can you see it here? Vivian, users. Can you see the user here? Vivian. So that user has been created. So I can edit the users. I can say, okay, the number of maximum queries that she can run every hour is 50. The number of updates she can do is 20. The number of connections she can do, that is, number of times she can connect to the server per hour, is 5. Concurrent connection is just 0 or 1, right? That is, she cannot have two of her accounts running at the same time. And she cannot have her account running on two systems at the same time, right? So that's account limit. Then administrative privilege. What can she do? Is she an admin? Well, I don't want to give her DBA privileges. I don't want to give her maintenance privileges. I don't want to give her process admins. I don't want to give her user admins or security admin, monitor admin. All of these are predefined roles on the database, right? But I want that to be able to update. Can you see global privileges? I want that to be able to alter system, create table spaces, create user, create view, drop, delete, drop, create indexes, insert, perform insert, use select, and update, right? If I add that, that means that that user can now perform all of these administrative privileges. Can you see? All of these ones that are given to her, right? She can perform them, right? She can perform all of them, right? So if I want to add schema now. I want to add schema. So I want to add privileges for her on schemas, right? So there's no privilege yet. So if I say add entry, on which schema now? I want to give her privileges on maybe classic mode schema. So if I say okay, what can she do on classic mode schema? She can select, she can insert, she can update, she can delete, she can create, can you see this is DDL, right? Can you see DDL? Alter, reference, um, then maybe with grant option, if I apply all of that, right, that means that I have created that user. So this user can log in with username and password, can only run 50 queries per hour, 20 updates per hour, 5 connections per hour, can perform all of these administrative tasks that are given to her, can perform all of these schema privileges that are given to her. That is how to create a user. Now, what does it mean? Uh, once this user is ready to work, what this user needs to do is now this user would now have to log into the database, right? Connect. Then users have to log in with a what? With a username, which is Vivian, right? And password, of course. If I say okay, let's try it. Let's use that. Vivian. So Vivian password now is asking for Vivian's password. Something is wrong. Something is wrong with maybe the password, something, right? So I'm unable to log in, but you can see that I'm trying to log in as Vivian, right? So once I log in as Vivian, then Vivian is able to use the database, right? So
So that
is
means on that one, on that classic models, I'll be able to see all the your codes there.
no, not my codes. You can't see my codes. You can only work on your own codes. You can't see my own codes.
But using the database
You'll be able
that
to use the data that is the database. All the if we come to classic model, you'll be able to use. You'll be able to use the classic model now, right? This is the data. So you'll be able to use this database, everything that is inside of it. You'll be able to work with them, all the tables, all the views, all the procedures, everything that is there. Depending on the privilege that I give to you, I can give you privilege on just the customer table. Do you understand? So that is that about that, right? So usually there's more to all of this, right? There's more to all of this as it's where I just tried to explain them as simple as I want. I can delete this user now, Vivian. I just delete the user, and that user is gone, right? So if they sack Vivian, they will not sack you. If they sack Vivian, right? All I just
Amen in Jesus' name.
if I'd sacked Vivian, right, or fired her, all I just need to do is delete that user, and that user is gone, right? So basically, that is how we work with the database administrative privileges. So there is more to it. If you want to know more, you can research into it. And hopefully next year, I'm thinking of creating of doing a training that would a database administrator training, right? I'm thinking of doing one next year. So if you're interested, you can join that training next year. But so far, we have come to the end of this SQL training. And what does that mean?
Sir,
Yes.
sir, you were talking about GitHub or something, that how to
Yes,
use
don't worry.
create
I'll talk about it. I'll talk about it.
okay, sir.
Right? Yes. One more thing I want to talk about before going. Right. Look at this query. Right. I want you to look at this query. So yeah, we all have this, right? Remember, you all have this schema. I gave you this schema, right? And if you look at this schema, this is what I want you to learn from this schema. And this is the way we work. When they were creating these schemas, right? We only added primary keys and not null, right? Primary keys and not null. We created all the tables, added primary keys and not null to them, created all the views, just primary keys and not null. Then we began to insert into those data. Insert into them each. So I want you to study, go back and study this code, right? Every one of it, every one of us should go back and study this code, right? You should be able to understand everything from beginning to end now, right? So they began to insert data into each of the tables, right? Then after that was done, right? After that was done, all the data has been inserted. What happened in the end? You see that at the end of the insert is when they began to add the what? The foreign key. So the question is why? Now, the reason is because the tables that you want to link together must have the same data. Are you following me? If you are inserting and if you have added the constraint, the foreign key constraint on the columns before you inserted, it will give you errors. It will always give you errors. So what we do is we usually delay adding the foreign key. You delay adding the foreign key until when you have added at least a good number of data into that table, such that both tables now have data, right? When both data, so take for example, look at this situation now. We want to link, we're adding, we're adding we're altering the countries table here. Look at it. We're altering the countries table. We're adding a foreign key to the region ID column. Adding a foreign key to the region ID column, which is referencing the regions table, right? Now, the reason why this will work is because the country table has data in the region ID column. The region ID column has data in the region ID column. The region table has added these two columns now have data. The column region ID in the countries table has data. The region ID column in the regions table has data. So it's easier for me to add a foreign key to reference one of them on the other table. Imagine that one of them does not exist or one of them does not have data, then it will be a problem. That's why when you were doing it, it was giving you problem. I hope you understand. I hope Lola is here. Lola,
Yeah,
Lola was
I get
Lola.
it now.
So that is how it works, right? Or that's how it works, right? So all of them now have data, right? So what it does is that in adding the foreign key, just opposing the data to say, is this data and this data equal? Is this data and this data equal? Right? And they don't have to be equal. All you just need to do is that their names and data type is what it needs, right? So once that is done, it begins to juxtapose. Is this equals to this? It goes, oh, they're fine. Then it adds the foreign key. Then, and that's how it is done. So if you look at it, it is at the end of the code, at the end of the old table creation and all of that, and inserting and all of that I began to alter my tables and add foreign keys to them. So that is how they are done. That is how they are done. I hope I've been able to answer all the questions that has been posed to me so far in this training. Yes. Okay, so like I said, we have come to the end of this SQL training. I hope it was interesting. I hope it was insightful, right? I hope you enjoyed it, right? I hope you enjoyed it. I'm available for questions anytime, right? And then we'll have one more class next week, maybe just Saturday or maybe just Sunday. I'll let you know. We have a guest. We still have somebody to come talk to us. I still want us to have that feel of somebody, somebody doing awesomely well in tech to come and talk to us. One of my guys, right, to come and talk to us. Then also we have one more program to go through, which is an add-on to this program, which is Git, right? But Git is just will just be a maybe 2 hours, 3 hours training. It's not a long training. It's not a long. It's not a skill that takes hours, right, to learn, right? So we'll just go through Git, and the reason why you want to go through Git is that Git is used for version control and collaboration. But don't worry, we're not going to Git today. So next week, I'll let you know if it's a Saturday or Sunday that we'll be having that class, right? So that we can, and like I said, the class is going to be attended by a whole lot of people. I'm opening that class up to a whole lot of people. Some of my past students and all of that will be joining that class, right? So please come early so that we can have a beautiful time. So your project also will be communicated to you this week. This week that we're entering, our program manager will reach out to you and give you your project to run. Every student that goes through this program usually is required to do a project. That project is what will qualify you for your certificate. Out of about 25 or so people that did the first cohort, only about 15 of them had gotten their certificate. So I do not just do trainings. I issue certificate, and I don't just issue my certificate out. I give my certificate to people who I can see that their work is good. All right. So the ones that did the project and submitted the project and have gone through their project and they passed, I've given them their certificates. The ones that have not submitted, they have not gotten their certificates, even though they paid. Please, when you get your project, the project will probably be to create a database and insert data and all of that. Everything, it probably just covers everything that we've done, right? Please just attempt it. You usually have like between 2 to 3 weeks to finish your project. Attempt it so that you can get your certificate and move to the next level. There's a next level after this, which I'm hoping that you'll be interested in. So I'll also send our feedback form and send our feedback form to us. Also have I'll check. I have some gifts for us as well. I think we have some hoodies that we can still drop for us. I'll check. I'm not promising yet, but yes, I'll check to see if we still have those hoodies. I'll share them with us. So thank you, thank you, thank you. I'm really grateful that you took this chance to learn this skill at this time. The group is not going to be decommissioned. The group still exists, and we're hoping that at the end of at the end of the year, we'll be able to do an hangout, right? A tech hangout where we can just hang out, know ourselves, physically engage with each other, help each other, just just have fun, and yes, and collaborate, right? Network and collaborate against next year, so that we can begin to prepare ourselves for opportunities next year. Please let me know if you enjoyed this training so far. I just need to hear it again. If you where you think, of course, the feedback form is a very comprehensive form. I'm going to drop that on the group so that you can help me. Please and please and please and please help me fill the feedback form. Help me fill the feedback form is very essential for us. My assignment, I'll drop all the necessary assignment that is attached to this chapter and the previous chapters that we have done, so that we can have something to go through. Please do the assignment and submit. It is also part of the criteria for the certificate. I think I have
I want
covered
to beg
everything.
you for something.
Yes, please. What's that?
The code that you have, that inside value and all that. Can you please share it with us on the group again?
All right, I will share this code. This is the code. This one that you are seeing, right? I'll share this one with us. We actually have it, but of course, I've updated it while we are working in class. So I'll share all of this with you so that you can have it and use it to practice. I'll share all of this with you. This is just terrible. I'll share all of it with you so that you can have it. Yes, I'll share all of this with you right after class, with also with the class link and all of that, so that you can have them and use them to practice. Any question? Any question?
There's another one, no.
Yeah.
The one there's another one. The one, okay, yeah, this one. Oh, yeah, 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 that one. I don't know if it's the
This
same
one.
thing. No, the one you just showed now
This
before.
one.
Yes,
You
sir.
have this one.
Yes, I don't
Okay.
think.
I'll share both of them. I'll share both of them.
Okay, thank you, sir.
All right. Any question? Any question before we wrap up class today? Any question? Um. Oh,
I have a question.
please go ahead.
Oh, it's not about like the class. It's about I think for most of us, speaking
Okay.
for myself generally, I've been having exams and I have exams that is going to run till the end of this week, till December. I think that is it possible that after the GIT class, before our project, you sort of give us, I don't know, it's just a suggestion, maybe a week to catch up from beginning till end, because I feel that if we start going back to each slide, I mean, for the classes, when it's time for project, I don't know, it sort of gets muddled up. So, like, this week, you people should take the whole week to, I
Yes,
think
yes,
if
yes, yes,
we do three
yes. Of
hours
course,
a
of
day,
course,
I think
of
if we do
course.
3 hours a day, even if it's at midnight, so then you can say maybe we should ask you questions after then, like a week we
Yes.
get before project.
Now, the way it is actually is that, of course, I know that you just finished the program, and then you have questions, you still have materials and videos and all that to go through, right? Yes. So usually after the program, I'm first of all, I'm usually available to all my students as long as you have gone through me. If you have questions from now, maybe you did the program now, and 10 years after you have questions, you can ask me your questions anytime, any day, right? That one is certain, right? But for the case of catching up, yes, if you need to catch up with, I know that everybody needs to catch up, right? So we usually give a good number of gap for you to catch up with the classes before the project. Of course, we'll push the project to you, right? And you have a tentative date of submitting. But in between the time that has been given to you, you have your catch up time and the time to do the project, right? Like I said, it's usually between I gave the last batch 2 weeks, but they could not submit in 2 weeks. They submitted in 3 weeks, but I think I'm going to extend it this term. But I don't want to also extend it too much so that people don't just become lackadaisical about it. So I'm looking between 3 weeks and 4 weeks, right? So that you have about 1 week, about 1 week to 10 days to catch up, and then you have the remaining time to deal with the project and the assignments and all that, so that you can submit on time and get your certificate. But as for questions, when you catch up, when you're watching the videos and you have questions, you can always call me or chat me up. But I usually prefer that we put it on the group so that everybody can learn. But if you do not want to, you can just private chat me or just give me a call. Just a call or a chat away from you. And what this means is that you are in you and I are in a I don't like using the word mentor mentee, but we have a kind of relationship now that allows me to um, give to you more, right? I'm invested in your progress. That's basically what it means, right? So as I, as an individual, is moving on a journey, right? I'll also do all my best to be able to, to bring you along through trainings, through answering your questions, through sharing opportunities with you, with each other, through giving recommendations to each other on LinkedIn, or assigning projects to each other when we have projects. We're just in that kind of relationship where we are helping each other build careers, right? So, but of course, because I am in the game already, or I am ahead already, right? So it's more like I'm trying to bring you forward, but doesn't mean that you cannot bring, or you cannot bring opportunities to me as well. So, but we are in that kind of relationship, right? So I'll just say that it's some sort of mentor mentee kind of relationship, but I do not want to use mentor mentee, right? No, but maybe a teacher student relationship, right? Maybe, right? So that kind of relationship is what I'm talking about, so that we can benefit from each other. And yes, so you can call me in another 5 years and say, oh, Shehu, I'm having issues with this SQL query at work. I'd like you to help me look into it. And I was like, okay, let me see. Just send it to my mail or something and get it sorted. And I'm like, I can just call you and say, are you available for this job in Tokyo or in New York? I think I have an opportunity in New York that I think you'll be interested in. It could come in any form, right? But we are friends. We are in that relationship already. So, and of course, next year, I have, even this year, I still have trainings coming. I have one more training coming that I would want you to key into, but we'll discuss that much later. Apart from that's the visualization training, right? Remember that we are going on a journey of data science. So this is just the beginning, right? So we have visualizations, then we have data science in Python that I want you to do. And really and truly, you have to key into it. I will have to drag you along. If it's for me to come and meet you in your house, right? I have to drag you along. I want to drag everybody along such that you can benefit in this new era that we have, this new dispensation that we have. So you are still going to see me in your DMs and your faces and your phone calls in from now to next year, right? Until when we are where we want to be. And I'm like, oh yes, I have created a data scientist in you. Then I'll be glad, right? So that is what we have. Any other question before we wrap up today? Any other question? In the absence of questions, thank you for coming. It's been awesome spending the last 8, 9 weeks with you. I think we've done 9 weeks already, right? It's really awesome. It's really awesome. It's really awesome. Remember that we had the first 2 weeks, we didn't really do much, right? Until when we began to dive into it. So, but it's a beautiful journey with you guys. I love you guys. You'll see all the information that I need to pass to you on the WhatsApp group, starting from this night, right? So thank you for coming. I'll drop the videos for last class and this class also to this night or tomorrow morning. I don't have light presently, of course, we're in Nigeria, right? So my laptop is almost dead. So if I can't drop it this night, I'll drop it tomorrow morning, first thing tomorrow morning, for you to be able to access. Please engage them. Then I will need your help with some social media, join us on social media. I'll drop all of those informations with you. And yes, I'll be needing your recommendations. I also want to recommend you, right? I want to recommend you and say that, yes, I trained this person, or this person is now an SQL expert, or this person now an SQL developer. So I want to do that to your LinkedIn profile so that it gives you a boost for opportunities and all that. So we'll be doing all of that during the week and in the coming weeks as we help each other grow. Thank you for coming. I'm really happy to have you. Do have a wonderful evening. God bless you. Love you. Peace out. Bye.
Bye.
Thank
Thank you.
Bye.